Okay, so one question that will be asked on the ACT, therefore, in my class, it says if x plus 3 is a factor of x cubed minus 3x squared plus kx plus 5, then k equals what? Okay, so that's the question being asked. So first of all, it says x plus 3 is a factor. If you remember from long division, you know it's a factor, so it is a factor if you have a remainder of 0. Okay, so what we're actually going to do is we're going to set up a synthetic division problem where we're going to work a little forwards and a little backwards and meet in the middle where k is at. Okay, so really what I have is I have x cubed minus 3x squared plus kx plus 5 divided by x plus 3. And we know that we have to have a remainder of 0 because we're told x plus 3 is a factor. So let's get our little box ready. So I have x plus 3 equals 0. X equals negative 3, so negative 3 goes in this box. So I have x cubed, x squared, x, and constant. So my coefficient for x cubed is 1. My coefficient for x squared is negative 3. My coefficient for x is k, and my constant is 5. Okay? We know, remember, this spot is always the remainder. We know that we have to have a remainder of 0 because x plus 3 was a factor. Therefore, what you have to ask yourself, what plus 5 gives me 0? Negative 5 does. So the number that goes in that slot is negative 5. So now what I have to do, so I've worked as backwards as I can. So now what I have to do is start working forwards. So I'm going to bring down my 1. Negative 3 times 1 is negative 3. I have to add them together to get negative 6. Negative 3 times negative 6 is 18. Okay? So what I know here is that k plus 18 gives me whatever numbers in this slot. Now I can actually figure out what numbers in that slot because negative 3 times this number has to give me negative 5. So we can actually set up a little equation. Negative 3 times the number has to give me negative 5. Therefore, I need to divide by negative 3. So n is going to be 5 over 3. So I can actually fill in this slot here with a 5/3. So when working backwards, some people go straight to that. I usually wait until I work forwards. It's totally your call. So now I have another equation to solve. So again, negative 3 times this number gives me negative 5. And I know I have to have negative 5 here because I have to get 0 as my remainder. So now I have another equation. K plus 18 equals 5/3. Okay, so what I'm going to have to do is I'm going to have to subtract 18 from both sides. So 5/3 minus, and now I'm going to have to get that over 3. So what, I get 54 there? So 5/3 minus 54/3 ends up giving me what, negative 49/3? Yeah. So that is what k equals. K equals negative 49/3. Now, I will say on the ACT, sometimes they will give it to you in mixed number form. I would accept either mixed number or this improper fraction. So you could give me negative 49/3, or you can convert that into a mixed number, which is negative 16/3. So that would be the answer for k for that. Let's look at another problem. The directions say, use synthetic division and the given factor to completely factor the function. So what that means is you're given a polynomial function, x cubed minus 4x squared minus 9x plus 36. So you're given some kind of polynomial function. In this case, this is the polynomial function. And you're given one of the factors, which is x plus 3. Okay? So you're given the polynomial function and one of the factors. And they want you to completely factor it, which means you should have a couple of binomials. This is one of the binomials. And we know it's a factor, so therefore we know we'll get a remainder of 0. So first we need to divide synthetically. So I have a negative 3 in there. I have a 1, negative 4, negative 9, and 36. So remember this is x cubed, x squared, x, and my constant. And I'm going to bring down my 1. Negative 3 times 1 is negative 3. I add those together to get negative 7. Negative 3 times negative 7 gives me a positive 21. Negative 9 plus 21 is a positive 12. And negative 3 times positive 12 is negative 36. So I get my remainder of 0. And this becomes x squared minus 7x plus 12. With a remainder of 0. Now, I don't really need that remainder of 0 because what the question's asking, they want you to factor completely. So you need to completely, they need you to completely factor this function. Okay? Well, here's one of your binomials, but now I need to factor this. Okay? So, I have my x plus 3. That's one of them. I should end up with 2 other binomials. And in order to find those 2 other binomials, I have to factor this. So I have negative 7 here, and I have 12 there. So I can do negative 4 and negative 3. Notice that a is 1. So I can just take what I've got, x minus 4 and x minus 3. So that's what I can put up here with my other factor. And I know that x plus 3 was a factor because it told me. Use the given factor, so I know that this is one of the factors, and these are the other 2. So this is this binomial, x cubed minus 4x squared minus 9x plus 36, completely factored. Okay, so I was able to completely factor it with those 3 binomials. I have one more problem for you. And so the directions are write a polynomial division problem that has a quotient of 2x minus 1 and a remainder of 4. And this tends to freak people out, but actually it's pretty freaking amazing, to be honest. So, really you can have anything that you want. Your quotient has to be 2x minus 1 and your remainder has to be 4. So what I'm going to do is I'm just going to pick a random number. I'm going to pick 2. So this is just one example of what you could do. Every single person could end up with a different problem, and that's okay. Okay? You just have to have the same answer of 2x minus 1 and 4. So what you do, you're really working backwards. Remainder of 4 goes there. I need a negative 1 here. And I need a 2 there to have my 2x minus 1 with a remainder of 4. So, if the 2 is here, remember that the starting number just has to come straight on down. So that 2 comes straight down. And then I'm just going to work kind of backwards here. So 2 times 2 is 4. So I have to ask myself, what plus 4 gives me negative 1? Negative 5 does. And then I do 2 times negative 1, and that's negative 2. So I have to ask myself, what plus negative 2 is 4? That's 6. So now I have my original problem here. That is going to be 2x squared minus 5x plus 6 divided by x minus 2. I took it from here because remember, I have to go backwards with this, and x minus 2 equals 0. So the actual answer is right here, this 2x squared minus 5x plus 6 divided by x plus 2. That's writing a polynomial division problem that has a quotient of 2x minus 4 and a remainder of 4. So truly it all depends on what number you put right here. Okay? That's really what will be dependent on the rest of your problem. So you have a lot of freedom with that, which is pretty cool. And it can be scary, but cool for the most part. And so these are all of your notes that you need for synthetic division.